This lesson is meant to formalize the first derivative test for increasing and decreasing. The first derivative test is more appropriately thought of as a sign test. First derivative test is a sign test or a sign test on f prime. Sign test on f prime to determine where f, the original function, is increasing, decreasing, where there might be an extrema, or where there might be some other thing going on. But the big thing to point out is it is a sign test on f prime. So at this point, we're comfortable, or we should be comfortable, comparing two different functions. So we compare f and we compare f prime. And what we're looking for is information from f prime, like where is f prime positive, where is f prime negative, and where's f prime 0, to determine if the original function is increasing, decreasing, or a possible extrema. A couple of other side points that will come across mostly in context is that if f prime does not exist, but f exists, we could be talking about a situation where we have a cusp. Also, if f prime is infinite, meaning it's a divide by 0, we could be talking about a situation where we have a vertical asymptote. We've encountered examples like this before as we were preparing, but these do come up from time to time. So let's define what we mean by increasing. The formal definition for increasing is that for any x1 less than x2, this implies that f of x sub 1 is less than f of x sub 2. I always, in math notation, like to think of, okay, now in English, it means that if x's are increasing, y's are increasing. And likewise, decreasing means the opposite. It means that for x1 less than x2, f of x1 has to be greater than f of x sub 2. So that formalizes the definition of increasing. And now we move into some examples. So one example would be, let's start with f of x is equal to a x to the fourth minus a 4x cubed. And we're going to do this on the open interval, negative infinity to infinity. So our analysis of this now looks at what f prime is saying. F prime of x is the function 4x cubed minus 12x squared. And a good thing to look at is also the factored form of this. So the factored form would be 4x squared times the quantity x minus 3. And we're also going to look at where this is equal to 0 to identify some critical values. So critical values of this would be at x equals 0 and at x equals 3. There are no values that divide by 0 occurs. Then we do a sign test on f prime. I look at 0, I look at 3. How you build the sign test is based on your experience and your comfort. We can plug 4 in and we get a positive number. I know that it's going to change sign around 3, but I know it's going to keep the same sign around 0. Since the factor of 0 comes from the fact that the x is being squared, that's going to play into whether the sign changes or not. And you can test different values to verify that. A sign test should not be the thing that throws you off. So what does this tell us about the graph? We know that f is now decreasing on negative infinity to 0 and 0 to 3, since f prime of x is less than 0. And we know that f is increasing on 3 to infinity, since f prime of x is greater than 0. Now what about at 0? Well, if I look at the graph of what f prime was doing, f prime was negative, which means that we'll look at f, not f prime. We know that f had to be decreasing then it hits a momentary spot, then it continues decreasing, then it turns and goes positive. So this right here was what would have happened at x equals 0. We see the graph is decreasing, decreasing, then we have x equals 3, and then it goes to increasing. And this matches because this is a y equals x to the fourth. It's a fourth degree polynomial. But this also, if we look at the sign test, we know that at x equals 3, there is a local min since f prime of x is less than 0 when x is less than 3, and f prime of x is greater than 0 when x is greater than 3. We talked a lot about what the AP graders want to see. This is what they want to see. We know that at x equals 0, there is no extrema. So how do I know that? Well, the sign test was really important to say that. It's no extrema because there's no sign change on f prime. So to summarize, the first derivative test for increasing, decreasing, and extrema. Some steps, and there's no specific process of this, but some steps include um, find critical values on f prime, do a sign test on critical values, and then your justification and your interpretation. So you interpret what you have and you justify what's going on. Now, I want you to notice how I did what in essence is an open interval on this. And this is because oftentimes we talk about a closed interval. So when it's a closed interval, we have another test that we have coined the candidates test. And this is for absolute extrema on a closed interval. And we've seen this a couple of times, but in a candidates test, we identify all possible candidates for possibly being the absolute extrema. We look at where f prime is equal to 0. We look at where f prime does not exist, but f exists, including where f prime might be infinity, but f exists. We look at all those possible candidates. We look at which ones are possible mins and maxes by doing a SIGINT test on the critical values of f prime. And then we check the y values, or the outputs, of all the critical values and the endpoints. And by checking, what we mean is we plug them into a T-chart and we see what their outputs are. And that's it.